A lot of the math that engineers need to do is impossible to do by hand with a pencil and paper or with a handheld calculator. In cases like this, we often use computers to do some of the tedious mathematics. One software package that makes it relatively easy to do computational modeling of engineering systems is Octave. This video introduces the Octave interface and performing basic tasks such as simple arithmetic operations, defining variables, and saving your work. There are two versions of the Octave program. One has a graphical user interface that allows you to click on icons. It's called New Octave GUI, G-U-I. The other version is New Octave CLI, which stands for Command Line Interface. The instructions I'll provide here are appropriate for version 5 of the GUI version. When Octave is first opened, you see what's called the desktop. The desktop is the primary interface in which the user interacts with Octave. At the top of the desktop is a desktop toolbar that allows you to perform a variety of common actions. This is the current folder window. This window shows the files and folders that are in Octave's current working folder. Keeping track of the current working folder and its contents is imperative. The path to the current working folder is shown here. You can change the current working folder by clicking here, selecting the new folder, and clicking Select Folder. We can use the current working folder to create and remove folders. To add a new folder, click the gear icon, select New Directory, name the folder, and click OK. To remove a folder, use your mouse to right-click on it and select Delete. Then select Yes. Now the folder and all its contents are gone. Here's the workspace window. This window provides a list of variables present in the workspace. This is the command history window. It displays all the commands that have been executed during a session, in the order they've been executed. Finally, this large main window is the command window. This is where you execute commands and script files and get your results. The CLI version of Octave is essentially the command window of the GUI version. You can still access working folders, script files, and all the other features available in the GUI version. The CLI just does all of it through commands only. I introduced some important terminology in the previous demo, so I want to reiterate some terms that you really should remember. Octave's environment is the set of files, folders, and variables you're using during your session. The desktop is the interface you use to interact with Octave. It's the first window that you see when you open Octave up. It contains the workspace window, the command history window, and the current directory window, along with the desktop toolbar that allows direct access to some common Octave functions. The workspace is a chunk of memory where the results of your calculations are stored. The command window is the most important window on the desktop. Commands executed at the command prompt are the primary way of interacting with Octave. The other windows on the desktop are mostly just to help you keep track of what you're doing at the command window. In the next demo, I'll perform some operations in the command window, talk about how to save the results of the calculations, and show you how to access Octave's help files. As an example of how to use the command window, let's do a simple calculation. If I type 1 plus 2 and press the Enter key, Octave will perform the operation and display the answer. This answer, 3, is now in the workspace. The workspace is a chunk of memory that stores the result of each calculation. Each calculation requires a name. If no name is specified, the default is ANS, which is short for answer. We can provide our own variable names using the assignment operator, which is just an equal sign. If we want the result of a calculation to have a specific name, we can write the name, such as var, followed by the equal sign, followed by the calculation itself. Spaces do not affect command calculations. For example, if we type var2 is equal to 2 plus 4 and add a bunch of spaces in between, Octave ignores those spaces and provides us the result we'd expect without them. The variables in the workspace are displayed in the workspace window. Our current variables are named ans, var, and var2, and the values of each variable is displayed in this column. If you'd like to delete a variable, you can right-click on the variable and select clear, or type the command clear, a space, and the variable name to be deleted. After you've deleted a variable, attempting to use that variable in a calculation will result in an error. We can view the current value of a variable by typing the variable name and pressing the Enter key. If we assign a new value to a variable name, the old value gets deleted. To replace that value, you have to execute the command again. A shortcut is to go to the command window, which has a list of every command executed in the session. Double-clicking on the command you want will execute it in the command window. Another way to access old commands is hitting the up arrow on your keyboard, which cycles through the commands executed during the session. In the previous demo, I performed some calculations and assigned the results of the calculations to variables. In the next couple of slides, I'll provide some more details about Octave's arithmetic operators and rules for naming variables. First, I'll present Octave's arithmetic operators. Addition and subtraction are performed with a plus and a minus sign, respectively. There are two different multiplication operators, the asterisk symbol and the asterisk symbol with a period in front of it. As a shorthand, I'll call this the undotted operator and this the dotted operator. When working with scalars or single numbers, these act the same way. However, if the operands are arrays or collections of numbers, the dotted and undotted operators do very different things. We'll talk about those differences later after we start using arrays. Octave has four division operators: slash, dot slash, backslash, and dot backslash. If the values they operate on are scalars, slash does the same thing as dot slash, and backslash does the same thing as dot backslash. The difference between the forward and backward slash is simply which number is being divided by which. The numerator is always what I consider to be on the uphill side of the slash. So 4 slash 2 is 4 divided by 2, or 2. This is the same as 2 backslash 4, which is 4 divided by 2, which is also 2. Finally, exponentiation is done with a caret symbol or a dot and then the caret symbol. For scalar operands, both of these operators perform identical operations. For arrays, as you might have guessed, they don't. The order of operations in Octave is consistent with what you're probably used to when you use a hand calculator. Exponentiation is done first, multiplication and division are next, and addition and subtraction are last. Within operations of the same rank, operations are done from left to right. Parentheses can be used to modify the precedence, since operations in parentheses are always performed first. Now I'll do a few examples of using these operators. I can multiply 2 times 5 by typing 2 asterisk 5 and pressing Enter. I get the same result if I type 2 dot asterisk 5 and press Enter. Since the numbers involved are single numbers or scalars, there's no difference in what the two operators do. Later, when we're using arrays, we'll see that there's a difference between the dotted and undotted operators. If I divide 7 by 2 using the slash operator, I get 3.5, as I'd expect. Now I'll divide 7 by 2 using the backslash operator. To do this, type 2 backslash 7. This is still taking the number 7, the number on the uphill side of the operator, and dividing it by 2. 3.5 is still the result. I've just changed the way I do the calculation. As with multiplication, if the operands are scalars, the dot slash operator does the same thing as the slash operator, and the dot backslash operator does the same thing as the backslash operator. To illustrate the exponentiation operators, I'll take the square of 3. I can do this by typing 3 caret 2, which gives us 9, or by typing 3 dot caret 2, which still gives us 9. The operators do the same thing when the operands are scalars. Finally, let's look at some issues with the precedence of operations. If I calculate 2 times 3 plus 2 caret 2, I get 10. 2 squared is 4 is calculated first, then 2 times 3 equals 6 is calculated, and the addition is last. 4 plus 6 equals 10. If I calculate 2 asterisk, open parentheses, 3 plus 2, close parentheses, caret 2, I get 50. The addition of 2 and 3 is done first now, since it's in parentheses. Then the exponentiation is done. So 5 squared is calculated to get 25. Multiplication is after exponentiation, so the last thing done is to calculate 25 times 2 to get 50. Another example is 6 slash 3 slash 2, which results in 1. Since both operators have the same precedence, they're done left to right. So 6 slash 3 equals 2, and then 2 slash 2 gives 1. The results of mathematical operations are assigned to variables. Here are some variable naming rules. Variable names can be at most 63 characters long. If you create a variable name with more than 63 characters, Octave removes and ignores those beyond the 63rd. Variable names should start with a letter. Other characters can be any combination of letters, numbers, or underscore characters. Variable names cannot contain spaces, punctuation, or mathematical operators. Most special characters, like %, $, and so on, are not allowed in a variable names. One notable exception is the underscore symbol. Variable names are case sensitive. Capital versus lowercase letters do make a difference. There are several words in Octave that have special meaning to Octave and can't be used as variable names. Octave will display these words if you type the is keyword command and press enter. Finally, there are a number of predefined variables in Octave. These variables are created every time Octave starts. Some common ones are pi, the ratio of the circumference of a circle to its diameter, I and j, both of which represent the square root of -1, NAM for not a number, which would be the result of an undefined operation, and INF for infinity, or any number that's too large for Octave to represent. I'll start by typing is keyword at the command prompt. None of the words on this list can be used as variable names. For example, if I try to assign the value 4 to a variable named while, Octave gives me an error message. A variable named var4 is allowable. But trying to create a variable named for_var results in an error, since variables can't start with a number. Likewise, most special characters and punctuation aren't allowed. For example, my %var equals 3 results in an error. as does my exclamation mark var equals 4. We can't use spaces in our variables, so the variable my space var isn't allowed. Usually, if people want something that looks like a space in their variable name, they insert an underscore. My underscore var is allowed. Octave has a variety of built-in functions. For example, the function sqrt calculates a square root. So sqrt, open parentheses, 2, close parentheses, returns the square root of 2. Function names can be used as variable names. So I can set a variable sqrt equals 3. Then, if I try to calculate sqrt of 2, I get an error. If I clear the sqrt variable using the clear command, it reverts back to being a function. Finally, let's take a look at the built-in variable pi. This is also a legitimate variable name for me, so I can redefine it as pi equals 3. Now if I multiply pi times 2, I get 6. I've overwritten the built-in value of pi. I can recover the built-in variable by clearing my assigned value. In this video, I introduced some basic Octave features and terms relative to Octave's use. For example, we talked about creating folders, setting the current directory, Octave's workspace, and saving the contents of the workspace. We also did some basic arithmetic operations. In later videos, we'll do some more advanced calculations.